Hi, today we're going to talk about why to build your next IVI system with Qt and Android Automotive OS. My name is Miao Luo, and I work in product management at the Qt company, focusing on automotive. And I got Shemek, who's one of our partners at City Auto, working as technical project lead. I will be talking about a brief history of the brand identity transformation, and Shemek will be covering how Qt can enhance the user experience on top of the Android Automotive. In the past, one of the primary ways for OEMs to express its brand is through manufacturing. Basically, the exterior and interior through physical design are what determine the performance, shape, layout, material, and finish. You can see that 100 years ago, OEM was already trying to bring infotainment into the vehicles. Who would have thought 100 years later, infotainment is where the OEMs fight to differentiate? Fast forward in today's world, software becomes more important to create brand value. As more screens are added to the cockpit, with young generations expecting a smartphone-alike UX, UI, and apps, it is where OEMs are driving towards a seamless experience across multiple displays inside a digital cockpit. Just to show you what kind of seamless digital cockpit experience look like, here's an Qt-based digital cockpit. The passenger display on the right-hand side runs on Android Automotive OS. What are the challenges and solutions when building an IVI on Android Automotive? Let me hand it over to Shemek. Shemek, please.
Thank you, Mia, for this introduction. My name is Przemysław Nogai, and I'm working as the technical project leader for CD Auto. And like said by Miao, I will try to show you what are the challenges, but also advantages of developing for the Android Automotive OS using Qt. So we already know, thanks to Miao, how important is the brand identity and how it should be expressed within your IVI system. And how to avoid being in a situation like in this photo where we have a stock Lookalike for the Android OS. So this is what you will get after building that out of the sources without any modification. Of course, you could try to modernize your system UI, define the colors, but that's a lot of work, and that work can be limited thanks to the Qt framework. So what to do actually to land in the Qt application? So let's move forward. As the Qt application for the Android is based on the activity, and to be exact on the Qt activity, it also follows the rules for having the need of having the manifest file. And if you would like to land in the home screen application or replace the default home screen application with your Qt-based application, it's enough to add this line into your manifest file. So this intent filter line says that, yes, this application is ready to actually start behaving as the home screen application and replacement for the default one. So if we will look over the anatomy of what's further presented in the demo, you can see that we have this Qt activity, which is a wrapper to actually start Qt application. And our Qt application is based on the Qt application manager, which is a part of the Qt Automotive suite. Why we have chosen that? Let's keep it a secret for now. Let's say enough that you will need the entry point to the Qt application manager, which is C++ code. This is just a main file that enables to open the application and load all the required resources. And the benefit of using the Qt application manager, one of the benefits, is that it's supposed to divide the complex systems like the IVI system into smaller logical parts, and those parts can be grouped into two groups. One is the system UI group, and the second one is the QML apps group. That's by the default. And the system UI is responsible for building the frames for everything you display on the screen. Also, the role of the application manager is to control the life cycle of the application, so whether those are running or stopped. And also the role of the system UI itself is to compose the windows that are coming from the applications. So that's about the theory. Let's move to short demo. So if you remember or you were doing the development with Yocto or the embedded Linux, there is a boot to Qt distribution which allows you to easily start or kick off the development of your UI. And directly configure the system. So we can achieve something similar with the Android, but as you've seen, we don't have to build the Android by itself. We just need to provide the APK with this single manifest line, and we are landing in the rich UI, which can have the 3D elements like here, or the smooth transitions like in the beginning of the video. Of course, what's another benefit of using that is that we can customize the look and feel. So for example, we can retranslate the whole UI on the fly, and we can connect that to the Android settings responsible for the language chosen. So as you can see, I have retranslated the UI to the Arabic. I don't speak Arabic, but yeah, you can see that it's changed to the right to left writing for the whole UI. Let's restore that. And now we have once again left to right. We can, of course, modify the settings like the accent color, or we could change the whole look and feel. So what you currently see on the screen is the Neptune UI, which is a reference UI for the IVI systems built with Qt. It's using the Qt application manager and also presents the approach to the middleware. So regarding the middleware, that's a great benefit of using Android Automotive. So just think about how much time it took you in the last project to develop the middleware around the Bluetooth stack, and then to build the middleware to actually fetch the contacts from the Bluetooth, or play the media, or whatever else. That's always a huge amount of work to actually provide something meaningful for the UI. And once again, the Qt Automotive seats come into the vision with its Qt IVI module, which helps to actually create the middlewares. So imagine that your application is just a pure QML application, and you would like to access some middleware data, like I don't know, the available Bluetooth devices or the contacts. So what you would need is to use the Qt IVI, which can expose for you the QML extension plugin that registers all the required types. It also can provide you different backends that you can use. And this can be a simulation backend or the Qt objects backend, which we are using in the subsequent presentations. And if you will think about that, that gives you plenty of possibilities. Even if your middleware is not ready yet, you can simply use the simulation backend. And once you will start integrating with the Android middleware, then it's about this layer, so this middleware service layer. And as you can see from this picture, most of the parts are either delivered by the Qt IVI module, like Qt IVI core, by the Qt itself, like remote objects, or can be generated using the generators from the Qt IVI module. So basically, regarding the service implementation, so here also, it really nicely binds to the patterns that are offered by the Android Automotive. So for example, this, if you are familiar with the model view, the model pattern, probably you are also familiar with the live data concept or the mutable live data concept. So it's up to you just to develop the middleware service in the C++. So that's basically a gateway for the remote objects. And then using the JNI calls, you can interact with Java code that already uses the live data or mutable live data. So let's take a look on the code generation concept. So let's imagine that I would like to have a Bluetooth adapter abstraction for my QML files. I can describe that with the QFace language. I can say what will be the name of the import for the QML types. I can say what is the interface that can be used, but also, for example, I can from this interface I can expose some models or some properties, and I can define the type for those. So let's say that in my Bluetooth adapter, I have two models exposed. One is for the paired device, and the other is for the discovered device. And each device is simply consisting of the device name, address, and the connection status. So let's take a look. How can I use the generated code? So I can easily start by the import. And I can instantiate the interface instance. And I can, for example, whenever the Bluetooth state changes and the Bluetooth is on, I can start the discovery, which is another method of this Bluetooth adapter. At this point, I'm not interested in the implementation details because it's simply about the QML. Once having that defined, I can use that in my views. Like, for example, I have a Bluetooth settings panel where whenever there is a pairing request, I can use the interface method, which was generated simply to begin pairing or to connect my discovered devices and paired devices as the model for my list is. So basically, I have full separation from the middleware, and the middleware is fully separated from the actual service implementation. So let's check a demo for that. And as you can see, I'm opening the Bluetooth panel. I'm enabling the Bluetooth. If you remember, then my Bluetooth on the once the state changes to on is starting discovery. So I have the list of the discovered devices. I have started the pairing process. So I was requested by the key confirmation, both on my phone and on the device. Whenever I click the pairing process happens. So the device was added to the paired devices list via the model. And now my middleware or other fragment of the middleware in different interface is fetching the contacts list. So actually what you can see, the widget at the bottom is showing the recent contacts or actually my favorite contacts. So yeah, if I will scroll them, yeah, you can confront those with what I have on my phone. This is the list of my favorites. And now if I will go to the full view, once again, we have a nice transitions here, and that's hard to achieve with Android or plain Java development. I have a full contact list, reference phones, and my favorites. So basically, I'm connected fully to the middleware. Another special kind of middleware provided by the Android Automotive OS is the vehicle API. For example, the car API that allows to get the properties from the vehicle network. And here, the help to integrate that was that I got the pre-built module from the kit company that can connect to the or wrap the whole calls to the middleware, and then I can access window control or mirrors or HVAC. So let's check the demo. So actually, this demo is using this kind of middleware where I'm switching the temperature or different parameters, and that's all is landing in the vehicle HAL implementation, which in the production car should be connected probably to the vehicle network via CAN, maybe most, maybe automotive Ethernet. That's really an implementation detail that I'm not interested in. I have a pure abstraction of that, so I'm able to go through all these system layers. Another, or maybe the biggest benefit of using Android is a really vast ecosystem of the apps. So there's already plenty of existing applications and plenty of solutions. So imagine what you have in your Play Store in the inside your phone. So you have a Spotify, you have a lot of games, you have a YouTube. There's an application for everything. And now, thanks to Android Automotive and Google efforts, you can easily bring those to the car. And till now, what you have seen, everything was a QML application. So this setting application, or the media application, or the contacts, or this 3D car, it was all about the QML applications. And that's fine, because you could build your own OEM apps using QML, using the same styling. But there is a need, if there is a need of introducing third-party applications, then you can do that easily by wrapping the or creating another runtime for the application manager. So by default, for the QML applications, the application manager is using the QML runtime, while wrapping the native Android applications with Android runtime, let's call it this way, allows you to compose the plain Android applications into your system UI. So this part can display the plain Android applications. And that's really important, as with Android Automotive. There is no possibility to actually do what you know from your phone, which was the application widgets. That is deprecated. Now you need to use the activity view, which allows you to host the activities. And that's exactly what this Qt application manager does for the native applications. So let's check how it works. So as you can see, I have a list of native applications, not only the QML applications. So for example, I can start the native contacts application, and I can move it around the screen, which is not so easy if you are doing that with plain Java. And here I have a gallery application, which allows me to play the media. And I can add another application, like, for example, the cloud application. And as you can see, I have two active applications at the same time. Now I have added the calendar, and I can go to the full screen mode, and it's still composed within the Neptune UI build system UI. So yeah, as you can see, it's adapting to the size. For example, maybe I would like to open the native settings application. And that's all possible and feasible to do that, right? So once again, I can move the native applications around the screen. And let's not forget about the special category of the applications for your Android device, which are games. So is it possible to integrate the games into Neptune UI or into the Qt application manager in general? Why not? This is still a plain Android application. So let's have a quick demo for the Super Tuxcot. Yeah, so this is a 3D game. As you can see, I'm running this game and still the native clock is running or timer is running. But maybe I would like to hide it. So let's hide it and have more space for my game. By the way, I'm really poor at gaming, so don't I don't try to show my gaming skills here. It's just to show that you can run a 60 FPS game and still have the system UI that is built with QML. So actually there is no C++ code, not a lot of Java code. The Java code is only required to connect to middleware services, but all can be built with QML, for example, with the Qt Design Studio, where you can split the creation of the look and feel for the designers, and then attach to that to the actual middleware by the developers. So that was all I have prepared for you. I hope that you enjoyed the session. Of course, probably you have a lot of questions. Then let's move to the questions round. Thank you.